Hello friends, welcome you all in my YouTube channel. Dr. DM Sirsat here. Today I am going to discuss photochemistry part 2nd. In earlier lecture photochemistry part 1st, we have seen the basics of photochemistry, means basic theory of photochemistry, electronic state, means triplet and singlet electronic state, selection rule, what is meant by allowed and forbidden transitions, and photosensitization. Friends, in today's lecture we are going to discuss very interesting and important concept, that is Jablonski diagram. Okay, friends, what is meant by Jablonski diagram? The various electronic excitation and de-excitation processes in an organic molecule can be depicted by using schematic representation is called as Jablonski diagram. It is a simple systematic representation of various excitation and de-excitation processes is called as Jablonski diagram. See, in this diagram, the electrons at a ground state absorb energy and go to excited state, either S1 or S2. This process is called as electronic excitation. Then excited molecule lose its energy in the form of radiative or non-radiative transition and comes to ground state, is called as de-excitation. Then there is again fluorescence, phosphorus, vibrational relaxation, internal conversion, intersystem crossing. There is a different types of excitation and de-excitation process in the Jablonski diagram. See, one by one is a process A is a electronic excitation. When a molecule absorbs light energy, it gets electronically excited and goes from S0 to S1 state. If excess energy is absorbed, it may go to S2. See, this electron at a ground state absorbed energy, then excitation of electron takes place from S0 to S1. If this electron get excess energy, again excitation from S1 to S2, means this process A and D is called as electronic excitation. Number second is a process B, vibrational relaxation. The electronic energy levels are subdivided into vibrational energy levels, and the molecule in higher vibrational level in S1 or T1, S2 or T2 lose energy by collision and comes to ground vibrational level is called as vibrational relaxation. Okay, these electrons at a higher vibrational level lose its energy by collision and comes to ground's vibrational level, means this process B is called as vibrational relaxation. Then next one is a process C, is internal conversion. The molecule can lose further energy by collision and comes to ground electronic state S0 by loss of heat, and this is non-radiative transition is called as internal conversion. See, this is the molecule from S1 to S0, means the excited molecule at S1 lose its energy in the form of heat. It is non-radiative transition and comes to ground state S0. This process is called as internal conversion. Then next one is a process F. Fluorescence is a very important term. The vibrationally relaxed molecule in S1 state may lose energy by emission of radiation of longer wavelength than that of the absorbed light, and this radiative process is called as fluorescence. See, this process B is a vibrational relaxation, and this vibrationally relaxed molecule lose its energy in the form of radiative transition and comes to ground state, and this radiative transition, this process is called as fluorescence. Okay, the next one is a process E, is a intersystem crossing. The S1 to T1 means singlet state to triplet state transition is forbidden according to selection rule. However, some of the vibrational levels of S1 state may have same energy as those of the T1 state. In such cases, the molecules may cross over the S1 to T1 state without loss or gain energy. See, the best example, lower vibrational energy level of this S1 excited state and higher vibrational level energy of this higher vibrational level of this T1 state is approximate same, and due to this electronic transition from S1 to T1 takes place, and this transition is called as ISC, means intersystem crosses, and this intersystem crossing, and this process is a process E. Okay, the next one is a process P, means phosphorus. The phosphorus is similar to fluorescence, means it is a radiative transition, but in case of fluorescence, the vibrationally relaxed molecule from S1 comes to S0 by losing some radiative energy is called as fluorescence. But in case of phosphorus, the molecule in the T1 state may comes to S0 state by emission of radiation, which called as phosphorus. The wavelength of this radiation is longer than that of the fluorescence as well as the incident light. Phosphorus takes place after a time delay but continues even after the source of light is removed. Okay, this vibrationally relaxed molecule at T1 state, it loses its energy in the form of radiation, radiative transition, radiation, and comes to ground state. This process is called as phosphorus. Then next one is a process R, is a photochemical reaction. The T1 state has longest life as their decay back to S0 is slow. Hence, they are most likely to undergo photochemical reaction provided that the energy is sufficient to break the bond. Means in T1 state there is a photochemical reaction takes place, and this process is called as process R. And last one is a process S, is a photosensitization. In earlier lecture we have seen what is meant by actual meaning of this photosensitization. The molecule in T1 state may also transfer their energy to another molecule acceptor which gets excited, and the molecule in T1 state will come to ground state by non-radiative process is called as photosensitization. In a photosensitization, there is one donor molecule and another is acceptor molecule. Donor molecule absorb energy and goes to excited state S1, and then through intersystem crossing it goes to T1 state, and in T1 state it transfer its energy to another acceptor molecule. Then acceptor molecule gets excited and this donor molecule comes to ground state, and this whole process is called as photosensitization. These are the Jablonski diagram, details of this Jablonski diagram. These are very interesting and important concept. Thank you very much.